So now we're going to talk about composition with Go. And that's just going to give us a little bit of familiarity of working with data structures, in particular the struct type. And there's a nice article at goinggo.net, Composition with Go. And you could kind of dig through it and hear about Bill Kennedy's perspective on composition with Go. And he's the author of a good Go programming book and also does different trainings. So right here, right? 2, 3, 4 day trainings that he offers around the country, America. You can check him out.
I can't see what that is. Oh, it's golang.net.
So the website is goinggo.net. That's all right. Just ask me, I'll zoom in. And so I have some examples for composition with Go. And that code can be found on GitHub by going to repositories, and I'm going to Golang Web Dev. So this repository here, Golang Web Dev, and you'll see the files here under modularize. Yeah, you'll see the files there. It'll be like 0.11. Right now they're here because I haven't moved them forward, but they will be there soon. We'll move them in this video. So what is composition? Let me just give you a preview of that. Composition is like putting together a struct and composing your data structures. And so here's a struct with just name and age, right? And then we do a struct literal here. So we say the variable P1 is of type person. And here's the struct literal. And we do name and age and then just give it values. And you need that trailing comma. Well, the cool thing about composition is you can start to do things like this, where you have type person, and so you might have heard that Go is all about types. It's a different type of object-oriented programming, and it is object-oriented, but it's not like the way that you're used to it. And you could go to golang.org, and you could go to Documents, and then into the Frequently Asked Questions, and then search for object-oriented OOP. OOP uses that. Where is it? OOP, the FAQ. I thought it was in here. Object-oriented. I don't know what I'm talking about. That sucks. Totally thought that was in here. What is the purpose? Status, origin, history, new language, guiding principles. Is Go an object-oriented? Object-oriented. That's what I was looking for, language. So that's the post you want right there. And yes and no, although Go has types and methods and allows us an object-oriented style of programming, there's no type hierarchy. The concept of interface in Go provides a different approach that we believe is easy to use and in some ways more general. There are also ways to embed types in other types to provide something analogous but not identical to subclassing. Moreover, methods in Go are more general than in C++ or Java. They can be defined for any sort of data, even built-in types, such as plain unboxed integers. They are not restricted to structs classes. Also, the lack of type hierarchy makes objects in Go feel much more lightweight than in languages such as C++ or Java. So kind of cool. And how's that work? So here you can see I've created a type. It's a type, just like an int's a type or a string's a type. I've created a type. It's a struct, and it has these fields. It's an aggregate data type. It's aggregating together different pieces of data. So the struct is kind of the catch-all where you throw stuff. We've been working with that, right, and passing that into our templates. We saw that 2 weeks ago. Gentry's like, but how would you do this? How would you do that? Throw it all in a struct, right, and then pass that into your template. And so, but then we could do another type, and we could embed one type into another type. And when you read Bill Kennedy's article that I just showed you at goinggo.net, he'll talk about promotion. And so the inner type gets promoted to the outer type, right? So here we have type 00. It's also a struct, and it has person. So I'm not going to use the word inherits, because that's more, comes with baggage and more the traditional OOP programming that we know from Java or whatever. But here we're embedding a person, a type. We're embedding a type, and the fields in that type get promoted. The inner type gets promoted to the outer type. And so I could use the fields from person just as if they were fields in 00, right? And the only time is if there was a collision, like if these both had name, then I will always, if they both had name, then I will always be, when I call 00 name or whatever, that's calling that name. And if I wanted to call the name from here, I would need to specify this is the name I want through chaining with a period. We could try that. All right, so we'll modify it, and I actually haven't done that in a long time, so I think I've said that correctly. But
wouldn't it just, if it's linking to the person, then wouldn't it just inherit the same name as the name in person?
right, yeah. So I'll just show you if there's a collision, if two types had the same name, and so collision is this has a field called name, and this has a field called name, and we've imported person, which has a field name. Now those two different variables have the same name. They're coming from different types, and so they kind of have a different different structs. A struct is a type, right? I've created a type here, type person, and it's a struct. And but that would be a collision. So let's look at without a collision, then we'll try it with a collision. So here's person, and then I added one more field, license to kill, and then I've created my variable for my template, right? So variable TPL is type template from package template, and it's a pointer. So we're only passing around the address. We're not passing around all of the data. So it's just a address in memory where this data lives. And then func-init runs, first thing to run, initializes our program, and parses all of our templates, which is just this one template. And then we do func main. And so func main, package main, you need to have both of those. And this is the entry point for your program after everything's been evaluated, right? And then func-inits have been executed. Now we're ready to start our program. This is for the initialization of the program. We go into the program and we create a variable P1 of type 00. And this is, what do they call it? I forget the exact name. I was just saying it, but I'm a little bit tired. This is a struct literal. And so I'm not 99% certain that that's the right one. So I'm going to go to Golang. And where do I look? The two places I look for official documentation. One is Golang spec. So the specification, Golang specification. Another one is effective Go. And these are both the official sources. And you can see that by coming to golang.org and going to docs, just like you said. And you can find effective Go right here. And you can find the language specification right there. And those are the two places you look. So I'm just going to look for Command F and search for literal. And there's a lot of stuff that comes up. So I'll do struct literal. And here we have struct literals. The literal type's underlying type must be a struct. Composite literals, that's the word I was looking for. Construct values for structs, arrays, slices, and maps. Create a new value each time they are evaluated. They consist of the type of the literal followed by a brace-bound list of elements. So the type followed by a brace-bound list. So composite literal. For struct literals, the following rules apply. An element list that does not contain any keys must list an element for each struct field in the order in which the fields are declared. And so if I wasn't listing, another way I could have done this is instead of listing the keys right here, right, like these are the keys saying which field, I'd have to declare them in order. So for instance, if I was just to do, this, I could do P0 colon equals, and this would be a person, and I could just do Todd and 45, sorry. All right, and then I could do printline P0 name, P0 age. And I guess we should run it because the proof's in the pudding. So Golang Web Dev, CD 999, and we are in 09. We should see Todd somewhere, Todd 45 before our template was evaluated. So that's a composite literal. Yay! Also just a struct literal maybe, but composite literal will probably be the more accurate. What's up?
Is the license to kill, is that a variable?
It's a field in a struct, and yeah, you could say it's a variable. It's storing information, but a more accurate description would be that's a field in a struct. And so we could go learn, like, and again, I'm doubting myself because I haven't looked at the fundamentals in a while, and so it's easy to get slippery with language and just like create your own words to talk about it. So I'm trying to be precise with how I'm talking about this stuff. So we could look at, up here at the top of the spec, right? We could look at the different types, and there's the struct type right here. And so we could go down, we look at that struct type, and a struct with 6 fields. Okay, cool. All right, so they're calling them fields. And field name is T1, field name, they're calling them fields. Cool. This is good because I got to talk about this stuff on Saturday. So, all right, so here would be a struct literal or a composite literal. The type followed by, right, what did they say? Just basically curly braces, right? Bracket. And I didn't have to name the keys, right? The field's keys. I could have done name, age, right? Name the keys. But because I put them in order, I didn't have to name them. And so that's in that spec about, that's one of the rules that was highlighted in green. You didn't have to name the keys. So that's why I wanted to show you. If I'm naming the keys, I don't have to have them in order. I don't think. You know, always test to see. That totally works. But if I did it out of order without the names, it's going to throw an error. Because 45 is an int and it can't be used as a string. But if I put them in order, now no problem. So that's just to show struct literal. But what we're learning here is composition. And so composition has a type embedded in a type. That's one of the big ideas behind composition. So I just wanted to show types embedded in types. And so here I'm naming all the fields just to make it clear. I'm naming all the keys. And so here is a composite literal or a struct literal, whatever you want to call it, composite literal, and it's of this type, 00, and the key person is what? It's this, right? It's a person, composite literal, name and age, and then license to kill, false. And then I execute my template to standard out, pass in that data, right? And so my template takes that data and prints out name, age, license to kill. Notice that those types got promoted. Okay, so I didn't have to specify, because this is person, I didn't have to specify person.name. What would happen if that's there? I don't know if that's going to blow up. Imported, not used, funct. Well, that's an easy blow up. That's easy to fix. It's fine. Oh, person.name. Person is an unexported field of struct type main 00. So I might need to do this. And this is an interesting thing about Go. Now let's try, well, down here now I need to do, hey, I have person, the field is this. All right, it's a person. And so let's see what happens. Person.name, I need to come over here and get my capitalization correct. Worked. And so you don't, like a lot of things, Go is about simplicity, keep it lean, keep it clean. I don't want any stutter like in Java where, object.object or whatever, like, Java has a lot of like repeat, repeat, repeat. I don't want extraneous code. I want my code to be very readable. And so in Java you'd say public private. We don't, and here we just change the case. Lowercase, not exported. Uppercase, exported. Exported means you could take it out of whatever package it's in and use it somewhere else. Public private in Java? Okay.
Well, I don't really know Java, but I know something.
Good. So yeah, save yourself the headaches.
Java's great.
Gentry's awesome. Oh, to be a bachelor with nothing but free time to code. So, beautiful, right? All we do is change the case and it becomes exported or not exported. Don't say public, private. That's Java.
Okay.
Go intentionally has a language for talking about the language.
So what would you say in Go then?
You would say it's exported or not exported from the package. You would say it's visible or not visible outside the package. So exported, not exported, visible, not visible, those are the words that I've seen used for talking about it. But don't say public, private. To be precise, if you want to be precise. So it's exported, not exported. It's visible, it's not visible outside the package. So that's pretty cool. I like it. Right? So we had to make this capital. But notice when it was lowercase, since these were capital, right? They were, and this is just like a little bit, I still haven't until I wrap my head around it or I don't care enough to go find the answer. Hold on. Oh, dude, I totally felt like I had to burp. You get that feeling like you got to sneeze and you don't sneeze and it kind of hurts. I just had that feeling like I need to burp and it kind of hurt because I wasn't able to. I need to drink more bubbly water. Then it'll come up. So it's kind of interesting. Thing I haven't wrapped my head around. That used to be lowercase. And this used to be lowercase. And these used to be lowercase. And 00 is lowercase, right? There, that did it. And then this one, we just need to bring this back to name. And we don't need these files. Let me just get them out of the way. So now that'll all run again. It's all running. And it didn't matter that these types were lowercase. I was still able to take it outside the package. It was still visible outside the package as exported because I sent it over to my template. Right? So I took that data and threw it outside the package because the fields were exportable. And for whatever reason, and like I said, I haven't gone and dug up the answer as to why. It's just one of the things which makes me kind of scratch my head, and I don't care enough to go figure it out, or haven't. But, hey, those are available, even though these are lowercase. Intuitively, I'd think I'd need that to be uppercase to export it. But, so maybe what they were thinking was, well, sometimes you don't want a type to be available outside the package. So this whole type isn't available in other ways, but through a template, I could throw that in and get to the fields. I don't know. So person, 00, person. So then we had the situation with the collision. So let's do the collision. And so let's try name, string. And then over here, I'd need this to, well, I'm not going to change that yet. So how would I, and then I could format this code, go funct. And so go funct, it applies formatting to the Go code. So if this was out of whack, and I ran go funct, it formatted it, which is cool. And if I wanted to format Go font, that'll format everything from my current directory downwards through the directory structure. So if I was at the top of a project, format all my code to look idiomatic. It's interesting, another word of Go I haven't thought about in a while. Idiomatic. Isn't that an interesting word? So when we talk about code, which is good Go code, we call it idiomatic. And we'll look up idiomatic. Using, containing, or denoting expressions that are natural to a native speaker, appropriate to the style of art or music associated with a particular period, individual, or group. Idiomatic. So if your goal is to write idiomatic Go code, Go is about productivity, groups working on the same code base. It's got name spacing with your packages, right, and your workspace that we learned about. So you have to have a particular workspace so that all that name spacing and going and getting code, go get, like that all works really easily and really well. But it only works easily and well if everybody's using the same convention. So you have to use that convention. And then idiomatic code, making everybody's code look the same. So some people aren't doing curly braces below, and some aren't doing it after a func, declaration or whatever. It's like everybody's code's got to look the same. So when you look at code that's idiomatic, no matter who wrote it, it's in the Go style. And that makes it easier for everybody to work on it together, even if a few people have to give up preferences. Right? So that's called idiomatic. And when you go fumped, you're formatting your code in the idiomatic way. So now we are going to do a collision. So you tell me, how do I now assign a value to that field with this this variable? What I do? You tell me where to go and what to do.
What was the question again?
How do I assign a value to this field in this variable? I don't know. Maybe I won't be able to.
Oh, it would just be name colon and then whatever you want.
There you go.
But why would you do that?
Comma. I'm just illustrating a collision because people always have questions about this. Name, like,
It doesn't
like.
make sense to
It doesn't make sense.
adopt the
It doesn't.
person struct and then add a different name to.
No, it doesn't make sense. This doesn't make sense. But if you start combining different things together and you're in a programming environment and you have structs with 20 fields and then you're going to embed another one in or whatever, and it's like, oh crap, we're combining our cars and our trucks and they both have a field for doors, and we're combining, we have a type car, we have a type truck, and we're combining that in a type vehicle, so we have all the data in the vehicle struct, and both car and truck have a variable door, right? Oh my gosh, they're both named door, we have all this code depending upon that, holy crap, do we have to go back and change it to door car and door truck? Or can we access them even though those two variable names are existing at the same, in the same struct and being promoted, right? What happens when they're being promoted? There's a collision. So it's just stuff that can come up.
So in that instant then, which one would get the priority?
Let's find out. Let's find out. So right here, we're just calling name, right? James Bond came out, right? But watch what happens if we do this.
Oh, and it put 56,
James Bond 56.
which is inside the.
Yeah. But watch what happens if we name it dot person. So from the type person, give me name, right? Ian Fleming, because it said, oh, you want from the type this one person, give me name. So you could access both of them even though there's a collision. And collision's my word. Cool, huh?
Can you blow that up so I can see it? But we're seeing both there. Did I miss you do something?
What's that?
But we see both. We're seeing James Bond, Andy, and Fleming. I can kind of
Yeah, I put right here it's dot name, which is the,
Oh, right, okay. Yeah.
you know, and then here I did dot person dot name, and that got to the one that was the Ian Fleming one. So I'm just going to take this out and leave it the way we found it.
So why do you have to have person, person inside in the func main, inside the P1?
Sure. Excuse me. Ah, I was waiting for that one. Let me just put this back. So I was just doing this to make it really clear what I'm assigning. Let's see if there's another way we could do it. Which one should we comment out? I guess it just does not matter. Boop, 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 boop. So maybe, see if this works. Would that make sense? Look at type 00 at the top of the field, or the top of the screen, the code. Can you see that, Nina?
Yeah.
And
So because they're in the same order, then you don't need to put the...
yeah, the keys.
Oh, I see.
So I don't know if that's going to run, actually, because it's like been a long time since I've fooled with this stuff in this way. Because you just get into doing it the way you do it. It runs. So this is composition. All right, so that's the point, is just give you a little bit more exposure to working with the Go language and passing data structures into templates. So I'm going to stop this video now because that's a good little, well, there's one more thing I'll show you. I'm going to take this, which one do you like? Either way. You can do it either way. You can declare, initialize, declare, assign, initialize, variable, type. You can initialize a variable with an underlying type of struct either way. I think that's the way you'd say it. Because the underlying type of 00 is a struct. I'm not 100% sure. I'm like 90% sure on that in terms of language precision. All right, so let's look at, so that's that one. And just for learning the GitHub stuff, I don't know how you all are with that. Git status. All right, git add all. Git, hold on, sorry. Git commit -m adds alternate way to declare, assign, initialize. Initialize. It's like that's not all on the same line. It's throwing me off. Initialize. Adds alternate way to initialize a variable. Let's do a composite literal, struct literal. It was kind of fun to talk about this because I studied the heck out of this a year ago. So it's kind of fun to get back to using these precise words. And then git push, right? So that's up there. And then we'll look at this and then I'll reorganize the code. So this one will be, let's pull them all up there. All right, so composite data structure. Look at another one. So here's main.go. And here, I like this one, right? It's like academia, Academic year is made up of fall, spring, and summer semester. And we saw this one, I think, at the beginning, the first week of class. And a semester is made up of, and I'm just going to put the term there so I could have the term. That would be fall, spring, or summer, or winter, or whatever. And then it's going to have courses, which will be a slice of a course. What's a course? A course will have a number, a name, and units. And so here we're using composition, right? We create a type, and then we're using that type here. And we create a type, and then we're using that type here. We're composing our program. And then to add data to that, it'd look like this. So year, and I'm just doing fall and spring. Fall semester, spring semester. And this is the struct literal. And a semester has a term and courses, right? Term. And here's a slice literal. So a slice of course. And so there's my course. And this is another struct literal. And you could do struct, whoa, I don't want to move that. You could do struct literals like this too. And when you do them in line, you don't need the trailing comma right there. If I was to do this like I've been doing the other ones, which was to be like this, right, I would need that trailing comma. But if I do it like this, I don't need that trailing comma. And notice I didn't use any of the keys there for that one, right? I could have also used the keys and specified number, name, units. But the code is much cleaner that way. So I could have also changed this to, so this is kind of cool. Right, not need the term or courses. But actually in terms of readability, I think that makes it readable. Fall, term, courses. So just another composition. And so I have a challenge here. Take the previous program here and change it so that you can pass into your template multiple years of classes. Have those multiple years displayed. You guys want to try it? All right, so you got the code. Go do it.